Ready? This video is looking at solutions to 56 to 61. And before you do that, you do need to look at the examples here, two examples, and also look at the what it actually is a secant, cosec, and cotangent, or sec, cosec, or cot is the abbreviation there. Okay, so very quickly going through. So what's cot? Cot is 1 over tan. So all you do is to get cot, you need to go 1 divided by the tan of 1.27, and that is your answer. Cosec is 1 over sine. So cosec of that is 1 over sine 0.2187. And whatever that gives is your answer. This one here, sec negative 0.4578. What's sec? Sec is 1 over cos. So 1 over cos of that negative bit there. Now this one here is a bit more interesting. 59. Why is it interesting? Because still horrible numbers like this, you've actually got pi over 3. And don't forget, pi over 3 could be a special triangle. Okay, so what's sec? Sec is 1 over cos. So 1 over cos pi over 3. Now, what is cos pi over 3? There's our special triangle involving pi over 3 and pi over 6. So cos would be square root 3 over 2. Beg your pardon. No, that's wrong. Cos is definitely 1 over 2, so that's a half. So what are you getting is 1 divided by a half, and that gives the answer of 2. Okay, ignore that sort of notes there. So the answer is officially 2. So sec pi over 3 is what? 1 over cos pi over 3. Cos pi over 3 just happens to be by special triangles equal to a half. 1 divided by a half is 2. Right, number 60, sec 4 pi over 5. That is nothing special in there. We can't, that's not special triangles. So what's cosec? Cosec is 1 over sine. So sine of whatever 4 pi over 5 is your answer there. Now this one here is cot. What's cot? Cot is 1 over tan. And now this is where it gets complicated. To be honest, it's probably easier to use your graphing calculator. Okay, just go tan of, make sure you're in radians mode, 2 pi over 3, and out would pop an answer. But if you're a purist, technically, if we're looking at tan 2 pi over 3, let's just make this a bit larger. So there's your tan curve. Okay, you've got this asymptote at pi over 2, and then you've got this repeating function comes up here and goes like that, and goes like that. Okay, so the period is pi, if you can sort of see that. So if we're looking at what? Tan of 2/3 pi, that is basically negative pi over 3. Now, okay, well, 2/3 pi by symmetry, that's this value is negative, but if we look at pi over 3, as we know from a special triangle, let's go up here. Tan pi over 3 is square root 3 over 1. Okay, so pi over 3 gives you positive square root 3, and by symmetry, you could argue 2/3 of pi. So it's the same distance from here to here as from here to here, but this is negative, so it's the way it's shown. So that's a minus sign there. So my logic is, if you can follow that, you're doing awesome. But in theory, this bit here could be given as negative square root 3. Now, if you go to the back of your textbook, you won't see this answer. Okay, it's frowned upon to have surds on the denominator. Now, if we were doing the complex number external, this would be covered. So basically what you do is you times both, you times, okay, that's a bit hard for me to draw so I'm doing nothing wrong here. I'm timesing the numerator by square root 3, that gives that, and that minus sign just goes to the top there. It doesn't matter where the minus sign is top or bottom. And square root 3 times square root 3 gives you positive 3. So that is a more purist answer. Yeah, so there we have it. Fiddly. The key thing here is just recognizing what the thing is. So sec is 1 over cos, cosec is 1 over sine, and cot is 1 over tan, or you could say cos over sine. So those are 4 things you really, these two here as well, need to just have locked into your memory. Good job.